We're going to do a rotation on a coordinate graph this time, so we will not be needing a compass or a protractor or anything like that this time. We're going to do one of the main rotations, which you will probably see more often than the compass type. This is going to be a rotation, remember, lowercase r, of 270 degrees around the point O, which is the origin, of quadrilateral FGHI. So there's FGHI, and we're going to rotate it 270 degrees. It'll be counterclockwise. So there's two ways you can do it. The first way, the way I usually do it, is by just simply rotating the paper and looking to see where the point goes. So let's start with F. So point F is here. We're going to rotate it 270 degrees. So around the origin, if we turn it, this is 90 degrees, this is 180 degrees, this is 270 degrees. So three 90-degree turns counterclockwise. So F is now here. So think about this as being a normal graph. So if this is 0, 0, I go over 1, 2 to the right and up 1, 2, 3. So 2, 3 would be my image. So 2, 3 would be 1, 2, 3, be right there. That would be F prime. Okay? Another way you could do it is by using the transformation rules, which I showed you in the notes. And for 270 degrees, it simply says to take X and Y, flip them around, and make the second number negative, which I actually wrote right here, the same thing. So you could have just taken this ordered pair, -3, 2, and it would have switched 2 and 3 and made this one the opposite. So -3 would have become +3. So that would have become that. And a lot of people like to do it that way. I'll actually do them both ways. So that's F prime. So now I'm going to do G. So G is here. Remember, it's a 270-degree rotation. So we're going to do 3 rotations of 90 degrees. So 90, 180, 270. So I'm looking for point G. G is right there. So this would be -1, 1, 2, 3. -1, 3. So come back normal and go -1, 1, 2, 3. Right there, G prime. If you're using this rule, the ordered pair -3, -1 becomes, you flip them around, -1, and then the opposite of -3 is 3, -1, 3, which is the same place I put it. Next one is H. H is here. We go 90 degrees, 180 degrees, 270 degrees. We're looking at point H, which is right there, at -1, +1. So we come over here, -1, +1 is right there. That's H prime. If we use this method, H is -1, -1. So H prime becomes, we switch one of them and then make the other one opposite, -1, 1, which is what we have, -1, 1. Last one is I, right there. We're going to rotate it 90, 180, 270. It becomes the point 1, 0. So 1, 0 is here. There's I prime. We can connect the dots if we'd like. And you can see the pre-image here and the image there. We also can get the last point by taking 0, 1. I prime becomes, we switch them around, 1, we make 0 negative, which doesn't really do anything, and it's 1, 0. So same thing we did with the rotations. And that's how we would do that problem. You can do it either the way I flipped it around, or you could use this particular rule. But you got to remember the rule or find it somewhere. Okay, there's that one.